So this is UKMT Pink Kangaroo 2022. It was only a couple of days ago. It's the intermediate maths extension for years 10 and 11. First off, really well done if you were invited to take this paper. You did a really good job in that case in the regular paper. If you weren't, then that's no problem. You can maybe use this video to try out some of the questions, see how many you would have scored. Let's get straight into it though. So she's got a box of 30 matches, wants to make the number 2022. How many more matches does she use essentially? So, well, twos use 5 matches, 1, 2, 3, 4, 5. Zeros take 1, 2, 3, 4, 5, 6 matches. So in total, she's going to need 3 lots of 5 and 1 lots of 6. So we add those all up together. And she's going to need 21 matches. We take that off of 30. And we have our nice warm-up question out the way. Good. Question number 2, actually another warm-up question, isn't it? Perimeter of an equilateral triangle is all have sides 12, so the perimeter is 36. Then we split up into square. Of course, squares have 4 sides the same, so 36 divided by 4 is 9, and we have a side length of 9. So both answers are 9, both of them, and really nice warm-up questions that are super easy. This one, maybe, they actually printed out this as a big picture and gave it out to every candidate, so maybe actually you just folded the piece of paper over to see what matched. Otherwise, you just kind of see, I don't really know how to explain this one. You can start by counting the boxes either side of the shapes to make sure they're the same distance away. Like this one fails because 3 boxes to this circle, but 4 to this one, so it doesn't quite work. And then you have to make sure that the corners actually go over the same corners, but this doesn't work here because this would reflect to a shape that looks more like this. So it's only the first 3 shapes that actually work. You have 3 of them. Question 4, so what we can do here is we can work out that each one of these tables is 2 across, 1 up. Of course, we can just see that based on here, 2 across, 1 across, 2 up kind of thing. And then we can just draw them around here. So 2 across, that's 3 lots of that takes us 6 across, so there's now space to put 1 vertically like this, and then you keep going, 1 across, keep going, 1 down, keep going, count how many you've got, and you get your answer. I guess you could have also considered areas, but again, you've got a very big version of this as a picture, so you might just want to draw over it a bit quicker. So this is the data for 4 apps on someone's phone, and half of the apps are halved, or 2 of the apps are halved in usage, the other 2 don't change. So we just need to compare this with easy answers then. So if we look at this one, so the top one has halved in usage clearly, the second one has also halved, but the third one has also halved as well, so that's 3 halves. Actually it's 4 halved, isn't it? Whereas only 2 of them halved and the other one stayed the same, so that's definitely not. Here, the first one hasn't halved, the second one hasn't, the third one has, and the fourth one hasn't, so that's only 1 halved, so that's not good enough. Third one hasn't, has, that's 3 of them, so that's not okay. Halved, 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 hasn't, so not okay. Halved, not halved, halved, not halved, so it'll be that one there. I've said this before in Maths Challenge videos that I've made, but if you're ever doing a question that's trial and error, strongly consider doing it right to left, because I'm pretty sure the writers of these questions just troll you by always putting the correct one last to waste all of your time looking through these ones. Consider doing it right to left, is what I would say. Number 6, 5 candidates in school election after 90% of the votes being counted. So, okay, well this is the number of votes. Let's add these numbers up and we find 45 votes so far, and that's 90% of the votes. So okay, divide by 9 to find 10%, and then times by 10 to find 100%. That means there are 5 votes left to come in. Now, when we look at this, who can actually win this with 5 more votes? Well, obviously Henry can, because he's already in the lead. India can also win, because she could, or I assume she could go up 5 to get to 16, which would beat Henry. Jenny could also go up by 5 to beat Henry, assuming these people don't get any votes, and so these 3 can go up, but those 2 can't, so there's 3 people who can possibly win this election. 7, this is just an incredible question, because it's about Pythagoras, right? There are right-angled triangles here, and you guys know Pythagoras is a squared plus b squared equals c squared, but and then you learn that this Pythagoras is about lengths, right? It's about lengths of a right-angled triangle. But it's not. It's not at all, because think about what a squared is. It's literally a square. The size of this square plus the size of this square is the size of this square. The areas. A squared, this side squared, which is the area of this, plus this side squared, which is the area of that, equals that side squared. And so the area of this big square here, since it's the hypotenuse of this one, is just 3 plus 22. There's actually no Pythagoras required here, as long as you actually understand what Pythagoras is saying. And then, of course, Pythagoras backwards, because we're looking for a shorter area, or actually I was about to say shorter side, we're actually looking for a smaller area is how I should have phrased that. 27 minus 8 is 18, oh, sorry, minus 7 is 18, and we have our area. Just a absolutely gorgeous question. Amazing, whoever wrote that. Okay, so we need to get from X to Y, and we need to travel through every little hexagon here. So initially you think, okay, well, we can go all the way around, but then we miss the middle one. So at some point we have to travel into the middle one and then back out again. So there's an acceptable way of doing this. Now, how many ways can we go into the middle hexagon and then come out again? Well, we could have gone in from the first hexagon, or we could have gone in from the second, or we could have gone in from the third, or the fourth, or the fifth, but we can't go in from the sixth. Because if we go all the way around and then come in from the sixth, we can't get it back out again because we've gone all the way around. So this would be another option that we could go in from the first one, but we can just go in from this one, this one, this one, this one, or this one into the middle, but we can't go in from this one. And so there are 5 ways of doing it. You essentially go all the way around, but you just sort of deflect into the middle from a choice of this, or this into the middle and then out again. Question number 9. Another question about 2022. I'm actually going to do this question in 2 ways. The way that's really obvious to do it is, well, there's the number of tiles. Remove every 6th, so you divide by 6, right? You just do a quick bus stop. 6 and 20 goes 3 with 2 left over, goes 3 with 4 left over, goes 7. And then you remove those 337 tiles to get that number. And then you remove every 5th. So you take this number and divide by 5. Again, a bus stop would be required here, but I couldn't be bothered to do one. That also gives you 337. Which you then take away to find out how many tiles are left, and then you remove every 4th. So you divide by 4, and again you remove it out. And again it gives you this same number, which is very suspicious. The answer is D, by the way. But this number is very suspicious, and this is how I did this question the first time. And I was like, well, that's crazy. Why does it give you 337 every time? And it keeps going. If you played this game removing every 3rd, then every 2nd, then every 1st, it would keep removing 337. I was like, that's weird. And then my memory just kind of jogged something, which is that when I was sort of quote-unquote practicing for the Intermediate Math Challenge and the Senior Math Challenge this year, not the Senior, sorry, the Intermediate one, I learnt that 2022 is 2 times 3 times 337, because you always want to know the prime factorization of the year that Math Challenge is. And so I was like, oh, that's interesting, that number, there it is. And the way this works is, of course, you can times 2 by 3 to say that 2022 is 6 times 337. And then when you remove every 6th tile, you've got 6 lots of 337 here. So if you remove a 6th, you only have 5 lots. Imagine you have 6 piles, literally 6 piles of this. Removing a 6th of those, you just remove 1 pile, and you only have 5 piles of it left. Then you remove a 5th of it, again, remove a pile to leave you 4 lots. Then you remove a 4th of it, and you have 3 lots of it left, which gives you this number here. And then it would keep working, of course. Remove a 3rd, and you just get to 2 lots of it, and so on. So yeah, really interesting question. Had some thinking to do there for those of us who are into that sort of thing. I mean, aren't we all? We're sitting here doing a Pink Kangaroo Maths Challenge. Aren't we all into thinking about maths? Anyway, question number 10. Centers of 7 circles and same line. The 4 smaller circles have radius 1. Okay, now this question is super easy for anyone who's done any kind of these problems before. I'll put a link in the video in the description below for more problems of this type. But essentially, all you have to do is realize you can move this shaded area to there and this shaded area to there, and then you're just looking at this problem. Right, you can completely ignore everything else over here. Just put this shaded area there and this one here, and then work out what this shaded area is here. Apologies for the terrible drawing, but this is PowerPoint. What am I going to do? So yeah, this has radius. The smaller circles have radius 1, so the bigger one has diameter 2, which means all I have to do is work out the area of the big circle and take away 2 smaller ones. So that's going to be pi times 2 squared. Take away 2 lots of pi times 1 squared. Of course, this is the radius of the big circle, this is the radius of the little ones, and you end up with 2 pi as your final answer. This makes 4 pi, this makes 2 pi left over. Question 11. So this person is some years old, and grandchildren are guessing the age. One of them is out by 1, 1 by 2, 1 by 4. So let's just guess the answer is 76. 76 is out by 1 year, out by 2 years, out by 5 years. So it's not that. So the answer isn't that. It's just out slightly by too much. 77 is out by 2 years, out by 1 year, out by 4 years, which is correct. So yay, the answer is 77. Except, just be a tiny bit careful here because of this answer, impossible to determine. What does that mean? How do you mean impossible to determine? Like, I can understand what none of the above would mean, but impossible to determine? What does that mean? What it means is, if you tried the other two, 78 doesn't work, but 79 does work. 79 is out by 4, out by 1, out by 2. And because you're not told what order these guesses were in, the age could be 77 or 79, which means it's impossible to determine. So a little bit of a sneaky question that they throw in there. But anyway, question number 12. So if we call the length of this rectangle x and the kind of height y, we can just go all the way around labeling it, right? X's and y's, so all the rectangles are the same. And now, because it's a rectangle overall, we know that 3x must equal 3y plus x, just looking at the top and the bottom. Which we can rearrange, of course. 2x equals 3y, which means x equals 1.5y, or 3 over 2y. So let's just replace that on these sides here. So let's replace these x's with 3 over 2y's. Then the length of this side here is, well, 1.5, 1.5, 1.5 is 4.5y. And the length down here, so that's the length over here, as we've just said. And the length over here, if we replace that with a 3 over 2y and that with a 3 over 2y, is 1 plus 3 over 2 plus 3 over 2. 1.5 plus 1.5 is 3, plus 1 is 4, so that's 4y. So the ratio is 4y to 4.5y. Just make sure you get around the order, PQ to QR, yeah, that's fine. Cancel the y's, double it up, and you get 8 to 9. You probably could have done that without algebra as well, but whatever. Question number 13. So, circular running track. It's 550 meters long, or all the way around, circumference, whatever. Both starting and finishing at the same point. We'll say at the top here. Rabbit runs clockwise, speed of 10 meters per second. Hedgehog anti-clockwise, speed of 1. Now, what that means is, if the hedgehog goes x meters around this way, or after such a time that the hedgehog goes x meters this way, the rabbit is going to have gone 10x meters the other way, because the rabbit is traveling 10 times as fast. So after 1 second, the rabbit goes 10 meters this way, and the hedgehog goes 1 this way. After 2 seconds, 20 and 2, 3 seconds, 30 and 3, and so on. Okay, so now that when they meet, that means this one has gone around somewhere here, and this one's gone all the way around here. But what essentially we can say is this distance, 10x, plus this distance x, must just be 550, right? Because we can just, for some value of x, this extends out this way, and this extends out this way to the point where they meet, and the distance in total is the whole circle, 550. Of course, we can solve this, and we can find x is 50. So what we can say is the rabbit has traveled 500 meters around, and the hedgehog has traveled 50 the other way, and then they meet. Okay, good. So after that happens, the rabbit continues as before. So the rabbit has 50 meters to go, because that's just the distance the hedgehog went the other way. Now 50 meters is clearly going to take the rabbit 5 seconds, because it's 10 meters per second. The hedgehog also has 50 meters to go, because it turns and goes the other way, but it only goes 1 meter per second, so that does that in 50 seconds. And so it's going to finish 45 seconds after the rabbit. Difference between those two times. 14. We've got a square, side length 1. W is the center, which means this distance is a half. That's good. And it also means this distance is a half, because U is also the midpoint. Or this distance, maybe I could say instead. Doesn't matter. 3 regions of equal area. Now the area of the square is 1, because 1 times 1 is 1, which means the area of each of these things is a third. This is the fancy therefore symbol. I thought I'd show you that. Fun. So the area of this trapezium is a third. So using the trapezium formula, we have a third, and this is going to be a bit complicated. I'm going to call this side A. But remember, a trapezium is a half times the sum of the two parallel sides times the height, or the distance between them. So this is a half, A plus B times height. It's just there's so many halves it looks confusing. Anyway, then we can times everything by 2. Then we can times everything by 2 again to get rid of this half. Then we can take away a half from both sides, and when you sort that out, you eventually end up with this answer here. I'm going to trust that you know, if you're at question 14 of a pink kangaroo, how to take away fractions. Question 15. This one took me a bit of time, and I was a bit annoyed at it because it's a bit of a complicated question. So we've got a football tournament with 8 teams. Each team plays once against the other team, so each team plays 7 games, or matches. Matches drawn 1 point is standard football point scoring systems. I should say non-American football, because I have no idea how American football works, but soccer, if you live in America. Standard point system there. At the end of the tournament, the total number of points gained by the teams was 61. Okay, we're looking for the maximum number of points that the tournament's winning team could attain. Now, there's a lot to think through here. If we want the maximum points that the winning team has obtained, what we want, I've said this, each team plays 7 games. What I'll first say is that means that 8 teams play 7 games, but if you say the answer is 56, it's not 56, that's not the total number of games, because, like, Team A plays Team B, but then you're again going to count Team B playing Team A, so we actually need to halve this down to find the total number of games. This double counts every game, so there are actually only 28 games played in total. That's the first thing I'll say. So 28 games played in total. Now, if you want to maximize the number of points that the winning team scores, you want them to have wins, obviously. But even more than that, you want to minimize the points everyone else scores. And the way to minimize points that everyone else scores is you want the other teams to get draws against each other, because draws have a net bonus to the total score of 2, whereas wins, because it's 1 each, whereas wins have a net bonus of 3. And so if I want the winning team to have as many points as possible, I want the other teams to all draw each other such that they don't take points away from this total, and I can instead give them to the winning team instead. Okay, so I want team 1 to get as many wins as possible. I want other teams to get as few as possible, which means other teams need to draw as many times as possible. Okay, now the first thing that I can just do here is I can say, is this answer even possible here? And I'll work my way backwards using the answers. So 21 points for the winning team. Each team plays 7 games. Of course, 3 times 7 is 21. So if this would only work here if if the winning team wins every game. Now, that would leave 40 points left over for the other 7 teams to win in their 21 games left over. Because the winning team played 7, so there's 21 games left over. Now, is this possible? It's actually not. Because if all the other teams all draw each other, 21 times 2 is 42. So that's 42 points. And that was where I used this logic that I had said earlier. If you replace one of those draws with a win, that just increases the total by 1, right? Because there are more points given for a win than a draw, because a draw is 2 points, 1 each, a win is 3. So the fact that 21 draws is 42 means that this is never going to work, because I can't score less points than drawing. I can only make wins, but they score more points. So this is not a thing that I can do. So then we try this. Now, the winning team has dropped 2 points, which means they must have won 6 games and drawn 1, and that leaves 42 points for the other teams to score. But I know I can do this because that's exactly 2 points per game, which is 1 point each. That means all drawing. So this is possible if team 1 scores 6 wins and draws 1, and every other team draws every other team all of the time. So the answer is 19. Quite a difficult involved question, that one. Actually, this question I did in a very difficult way, and then I found a nicer way of doing it, so that was nice. Okay, so this is a square here, so let's tick off the sides. Now, this is an isosceles right-angled triangle, which means this angle is 45, which means by alternate angles, this angle is also 45, which means this is an isosceles right-angled triangle, which means this length is equal to this one, and likewise down here. Now, the area of this grey square P is 45. But if you can imagine, you can just take this white triangle and kind of rotate it around this point and drop it down to here. And then we can see we've just got 2 identical squares. And so the area of this shape is just double the grey square. So the total area is 90. And likewise, this is the same, so the total area of this is also 90. And now I did this first in a much more complicated way, and then I spotted a really nice way of doing it, which is just to draw this square out here, this shape out here. I don't think I need any of these points. In fact, I think I'm about to show you the complicated algebra way, which I forgot to delete. I'll just leave it on the board here. If you want to follow my logic with this, feel free to. You can see the answer there. I'm going to take you through the much nicer way now, but feel free to digest what I put on the board there if you want to. This is the much nicer way of doing it. You simply draw this shape out nice and small, rotate it a couple of times and put it down again. And now the total area of the shape was 90, so the total area of this shape, that there's 4 of them, is 360, and you're just looking for 1/9 of the shape, because there are 9 of these squares, you're looking for one of these squares are. So just divide that by 9 and you get the answer of 40. So yeah, much nicer way of doing it. If you want to try and go through the algebra, you can do. Question 17, Veronica has a hand, and she puts 1 ring on her little finger, 1 on her middle, and 3 on her ring. Now, first thing I'm going to do is call these left M and right, the left, middle, and right, just because this naming system is annoying. So we're going to change the names of the fingers to left, middle, and right. Now, I'm actually going to take you through 3 ways to do this question, because I was really confused by this question, so hopefully one of those ways will help you out. The first way, if you know combinatorics, one order that she could remove the rings is left, middle, 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 right? Just order this way to this way. But a different order, of course, is this. And what we're really asking here is, how many ways are there to write this word, quote-unquote word? How many ways are there to arrange these letters into a new, different way of doing it? And that might jog people's memories if they've ever sat and done any combinatorics. The ways to arrange a number of letters is you count the number that you're trying to arrange, in this case 5, and you do 5 factorial. And then if there are any repeats, you divide by that number factorial. Now m repeats 3 times, so you divide by 3 factorial. I'm going to put, so 5 factorial is 120, 3 factorial is 6. If you have no idea what any of these things mean, either just wait patiently until I get to the next method that I'll do for this question, or I'm going to put a video link in the description about this method. It's really useful to know going into particularly senior math challenge, which I assume lots of you are going to quite soon. Really useful method to know here. The answer is 20, but I'll go into a different method here which is more reasonable if you don't know this method now. So you need to take 3 rings off the middle here. So you need to do 3 m's. Now, really, the way to think about this is there's a choice of where to put the L's and the R's. So let's just do the L's first. You can put the L in a choice of 4 places, either at the start, here, here, or here. So there are 4 places to insert the L, and here are the 4. And now you just do the same with the R's. You think, well, here there are 1, 2, 3, 4, 5 places to insert the R. And likewise here and here and here. I can't be bothered to write out all the options, but it's just going to be the 4 choices here times the 5 choices there. 4 times 5 is 20, and we get the answer of 20 again. So that's probably the more logical GCSE way you could think about it if you didn't understand or know combinatorics before you got here. The last way to do this question is actually the way that I did it because I was tired at this point. Just find a super systematic way of listing them. So let's pretend you start with an L, an M, or R. Right, if you start with an L, you could go to an LM. You could take the middle off first, or next, sorry, after the L. Or you could take the R off instead. And then you go from here, right? You go, okay, after you've taken an M off, what else could you do? Well, you could take another M. Over here, you can only take more M's. So essentially, I'm just finding ways of building up all the combinations of these. After you've taken a middle, you could take a right, or you could take another middle. And then after here, you've taken the left and the right, so you just need more middles. But here, you have a choice. You can either take another middle off, or you can take another right off. I just did it the other way around. And then, of course, you finish up. And again, this is just a way of systematically writing them all out without missing one. Now, this is going to be 4 options if you start with L. It's going to be the same here because it's just symmetrical. So there are 4 ways of doing each of these, and then you find ways to systematically list them when you start with M. So I won't talk through this too much anymore, but again, I'm doing the same thing here. I'm going to say I could do an L or an R or an M, and then from here I could do an M or I could do an R, and from here I could do an M and so on. Yeah. I can't be able to talk about this too much. I think you get the point. I'm just very systematically listing every single option I have and being really careful only to complete an option when I know it's complete and to not miss one either, and you end up listing them all very systematically. This is a skill. It seems super boring, but this is to be able to list systematically like this is a skill. The other 2 methods are much nicer, but in any case, probably about time we moved on because probably shouldn't do every question in 3 different ways. This is quite a nice logic question here. It's a very weird question, and if you haven't done very many logic questions, you might have been a bit stuck. 2 types of people: positives who only ask questions for which the answer is yes, and negatives who only ask questions for which the answer is no. When Mo met these other 2 people, he asked Bo and I both negative. Now, we just need to do a little gate here. We start by saying, let's pretend Mo is one of those positive people. Mo is a person who only asks questions with the answer of yes. So therefore, this answer has the answer yes. But if the answer is yes, then that means that he and Bo are both negative, because the answer is yes. But he's not negative, he's positive. That was our starting statement, so that's a contradiction. Maths uses these 2 symbols sometimes for contradiction, in case you wanted to be super extra. So we started out by saying Mo is positive, which means the answer to this question is yes, which means he's negative, which is a contradiction. So then you say, okay, so in this case now, let's say Mo is negative, in which case the answer to this is no, which means that either he or Bo or both are positive, but we know he's not positive because in this timeline we've said that he's negative, which means Bo must be the positive one. So Mo is negative, Bo is positive is the answer. Number 19. So this is just a bit of an algebra question. It's fairly straightforward when you get to it. Let's call radars R, sailors S, and cabin boys C. Now, and we can set up a couple of simultaneous equations here. Radars receive 5 gold, sailors 3, and cabin boys 1, and 200 gold was given away. So 5 times the number of radars R plus 3 times the number of sailors C plus 1 times the number of cabin boys C is 200. And we can do the same with silver. 10R plus 8S plus 6C is 600. And then just take this equation here. What you're looking for is the number of pirates. So you're looking for R plus S plus C. And you might have practiced this kind of thing before. You're trying to get R plus S plus C out of this. And just stare at it long enough to notice that if you just do this equation minus this one, you get 5R plus 5S plus 5C equals 400. Doing this, take away that. And then, of course, just divide by 5, and you get R plus S plus C is 80, so there are 80 pirates in total. Okay, so this question was a bit weird. You've got this kind of cube with a choice. You can put any of 3 shapes down, a cross, a triangle, or a circle. And it's saying, which of these combinations with some other number of circles is possible? Well, you stare at this for a while and you think, well, okay, this cube here is made up of 8 smaller cubes. And each of the small cubes, because the shapes aren't allowed to be the same on kind of across a line here, each of these smaller cubes must have one of each shape on them, because you can't have X and then another X either here or here. So you must have an X triangle circle once and only once on each of these cubes. But there are just 8 of these cubes, and the rule is the same for all of them. So you must have one shape on all of the 8 cubes, which means you just must have 8 of each shape, one on each small cube. And so none of these are possible, because you just must have 8 of every single one, of all 3. So none possible. 21. Quite a nice question, this one. 12 weights grouped into 4126. Seems logical to work out the weight of the last group. So I can just add these things together. If you know how to add numbers together starting from 1, great. It's just the end number times the number after it divided by 2. So in this case, 12 times 13 divided by 2, which is 78. I could put a video in the description actually talking you through that if you want me to. I'll do that. So yeah, the last group must be 78 minus 41 minus 26. So the piles are this. That makes 11. So the piles are these. And now it's tempting to not really know where to go from here, except 11 is quite a small number. So I thought, well, okay, what happens if you just add up the 4 smallest weights? 1 plus 2 plus 3 plus 4. That's 10. So the only way to make 11, I can't increase this weight by 1, because I don't have 2 2s, and likewise for these. So I can only increase 4 to 5. And so this pile must be this. Okay, good. And then you think, well, actually, 26 isn't that small a number, but I've already used all the small numbers. So what does 4, which is the smallest number I've got left, plus 5, plus not 5, because I used 5, what's 4 plus 6 plus 7 plus 8? Oh, that's 25. And now the same rule applies. I can't use a 5 because I've already used it. I can't use another 7 because I'm using one here. So this must go up by 1, and the only thing you can have is this. And now, of course, you could put the remaining weights in here, but the question asks which of the following weights is the same as the 9. It's 4, 6, and 7, and of those, the 7 is here, so 7. Good. 22. Lovely question. Really lovely. Just a great question. It's given you, I remember when I saw this question first, it's given you the diagonals of the squares. So it's given you this length and this length being 10 and 8. And I thought, oh, they're just being annoying. They want you to do Pythagoras backwards to find the actual, they're just wasting your time. Actually, they're not. They're really not. It's great. P is the midpoint of this square. So instead of writing an 8 across here, I'm going to do a 4 and a 4. And now, this diagonal goes from corner to corner, which means this angle is 45, and so is this one. And so does this one here. So this is 45, and so does this one. So that angle there is 90. And so the area of this grey shape is simply the area of this big triangle take away the area of this white one. Now the area of the big triangle is just a half times base times height, a half times 8 times 10. And then I take away the area of this one, which is a half times 10 times 4. And I get, well, I mean, we can work this out very quickly. This is 40, this is 20. I get the answer of 20. Really great question. Really great. Question 23. I looked at this question and thought, oh, amazing, number theory. Love it. Can do this all day. And then it turned out to be much worse than it was. The product of the digits of a positive integer n is 20. Now, 20 is 2 times 2 times 5. If you're ever asked about products of stuff, just do a prime factorization really quickly. Okay, so the number that this is talking about could be 225. But of course, it could also be 252 or 522. Okay. However, it could also, 2 times 2 is 4, so it could also be 45. Like 4 times 5 is 20. And then, of course, it could also be 54. Okay, so you sit there and you think, okay, great, got them all, except you haven't. The reason 1 is not a prime number is because then prime factorizations wouldn't be unique, but I could just shove a 1 into all of these. In fact, I could do it as many times as I wanted, and I could do it wherever I wanted, because 1 doesn't change the product from being 20. So they're actually just an insane, you could call it, infinite number of things you could write down that would do this. I'm not going to, obviously, because let's get back to the question on hand. Anyway, which the following could not be a product of the number when you add 1 to it? So when you add 1 to a number, you just obviously increase the last digit by 1. So okay, let's just do that. Let's just try and find ways. I've got lots of potential numbers here. Let's just find ways of making these numbers, was my logic. So okay, let's make this 226. Sorry, okay, sure. Let's make this a 46. Well, 4 times 6 is 24, so I can clearly make this. Can I make 25? Well, looking here, I can increase that by 1 to 55, 5 times 5 is 25, so sure. 30. Increase that to a 226. 2 times 2 times 6 is 4 times 6 is 24, so that's actually just a way to make 24. Or this one, that's 2 times 5 times 3, which is 30, so I can make 30. Can I make 40? Well, 40 is double 20, so I would need to find some way of timesing this by 2, which I can do by taking one of the ones that end in a 1. So if this becomes 2, 5, 2, this one apparently, 5, 4, 2, 5 times 4 is 20, times 2 is 40. So I can make all these, and I apparently haven't found a way of making 35, which means it must be the answer. Now, the other way to think about that is 35 is 5 times 7, which means somewhere in here you would need to get a 7. But if you look at all of your digits, because you don't have a 6, there's no way of making a 7. So this must be the answer, because there's just no way of making yourself a 7 that would actually allow you to do this. So yeah, answer must be 35. Only 2 questions to go. I read this question and I thought, oh my god, I've seen this question before, right? I'm sure I've seen this question before. I've definitely seen this question before. In case this looks like just a perfect drawing, it's not me who's done this, it's Kangaroo Grey 2016 question 22. I have seen this question before because I've done every single intermediate or UK maths challenge for probably the last 10 or 15 years, and so I had seen this question before. They just wrote exactly the same question without a picture, which is amazing. So yeah, I vaguely remember how to do this, but I thought I would challenge myself and find another way to do it, because otherwise it would be cheating. So what you do is you follow the instructions and you place circles around kind of the edges of each point with centers at the point. Now this radius, let's just say has radius, this circle, let's say has radius x. That means that this circle starting here has radius 16 minus x. And of course that's in both directions. So when you put a circle here, that must have radius 14 minus 16 minus x. Now just be careful with the negatives. 14 minus 16 is minus 2. Negative x is positive x. That's x minus 2. And likewise in this direction as well. And then you just do it again. You do 17 minus x minus 2 is 19 minus x, because the 2 negatives become positive. Then you do this circle. Obviously I can't draw because I've just drawn all the circles badly. But let's just pretend there's a circle here. It must be radius 13 minus 19 minus x, which is x minus 6. Same kind of idea as this. And then likewise down here is going to be x minus 6, except now we can say x minus 6 plus x, which is there, must be 14. And of course we can solve that for x is 10. And so now we actually work out the radius of the circles. This one is 10, this one is 6, 16 minus 10, this one is 8. So you can see how terrible my pictures are now, but I was just guessing when I did it. That one's 9, and that one, lastly, is 4. So the answer, the biggest circle, is the one centered at A. Again, I thought I would do that in another way just because I remembered that solution, so I thought it was cheating. So another solution is you be a bit more brave and you call all the circles different radiuses. Like you don't even use the fact of that you know the distances as you work around. Just call them all different letters. And then you make a bunch of simultaneous equations based on those letters. So A plus B is 16, B plus C is 14, C plus D is 17, and so on all the way around. And then you do this really cool little thing where you say, okay, what's this one take away this one? Like simultaneous equations. This one take away this one. Well, the B's cancel. You get A minus C is 2. And then you take this one and you take away this one. And you add this one. So you take away first, then you add. Because when I add, the C's cancel, and I get A plus D is 19. And then you take away again, because then you cancel the D's. So when you do this, take away this, you get A minus E is 6, and then finally you add again to get rid of the E's, and you get 2A is 20, A is 10, and then of course you work your way around, find the biggest one, and it will be A again. And that will be the answer. Okay, question 25. Don't want to be disrespectful to anyone, but quite possibly the easiest last question in any kangaroo paper that's ever been written. Just look at this shape from kind of flat into it. Look at one of these corners. I think is it called a plan? No, plan is from above. A front view. Look at it from the front view in GCSE kind of ideas. Front view, and look at this corner here. It's going to look from the inside a bit like that, where you're seeing this circle which is on the back of this shape down here, and then this circle coming down. It's going to look like this when you look into this corner, front view, and kind of slice out the front face, just looking at the two circles here and here. Now, the circles are centered in the middle of each face, and the faces are too long, so the center is one away from the edge, and likewise down again. Now, the radius of these circles is just there, right, or here, because the radius is the same all the way around, which means there's another radius here. All the circles are the same size, and now we just set up Pythagoras, because of course this is a right angle. 1 squared plus 1 squared equals 2r all squared, but of course it's asking us for the diameter of each hole, and the diameter is just 2r. So I just need to solve this for 2r. So 1 squared plus 1 squared is 2, square root, and we get 2r as root 2, and that is the answer. 3 lines of working for the last question is pretty good, and that's the entire paper. Really well done if people did well on that. And yeah, thank you so much for watching.